right. So the exponent laws. You have to take a seat first of all. Thank you. So you have to memorize the exponent laws. Now the names here don't really matter, but you do have to remember the exponent laws. And I mean, right now exponent laws probably don't seem like super important, but if you continue 20-1, 20-2, calculus especially, exponent laws come back into play over and over again. So it's good to know them. First one is the multiplication rule. We do this in grade 9. Should be pretty simple. So it's saying if two exponents have the same base and they are being multiplied, I would take those exponents, keep the base the same, and add them together. That's from grade 9. We kind of extend on that now by combining exponents with coefficients as well as more than one variable. So for example, if I have like 5x cubed y times 2x y 4, I should be able to take that and multiply it together. And if I'm going to do that quickly, I multiply my coefficients together. So 5 times 2 is 10, not an exponent law. The next part, though, taking x cubed and x. So really, I'm taking x cubed, timesing it by x. So same base. I add those exponents. If I add them, this would be x to the power of what? 4. Yeah, because this is an invisible 1. So I have to add those together. X to the power of 4. And y is going to work the same way, where I have to take y and times that by y to the power of 4. So same base, I'm multiplying, I add those exponents because there's an invisible 1 there. This would be y to the power of 5. Everybody, I'm assuming, memorized or knows that one. Division rule works exactly the same way. So same base. So if I have the same base and I am dividing those coefficients, or dividing the exponents, pardon me, I'll take them and subtract the exponents. And we can extend that into harder questions that, once again, deal with coefficients and that have multiple variables in them. So if I have 25x cubed y over 5x 1.5 y to the negative 2, I should be able to take those and simplify. Right? Generally, when they say they're like solve for a single positive exponent or positive exponents at least. So if I'm solving for this one, what I need to do is divide each term as if the other ones aren't even there. So 25 divided by 5 is 5. X to the 3 divided by 1.5 is going to give me x to the power of, this is technically 3 minus 1.5, so 1.5. And y to the power of 4 divided by y to the power of 2. So I would subtract those to give me what? Y to the power of 2 or 6? 2 or 6? 6, right? Because I'm going 4 minus a negative 2. So I'm going to get y to the power of 6. Okay. Next one's power of a power. And it's kind of broken down here to look at the multiple ways in which you can do power of a power. So power of power is just saying if there's an exponent outside of brackets, to distribute that exponent in, you need to multiply it to all of the other exponents inside of that bracket. So whether it's 1, whether I have to do that twice, whether I have to do that to both sides of a fraction, it's going to work exactly the same way. So if I had, let's say, 5x cubed over y to the 2 all to the power of 3, if I'm using power of a power here to simplify, I need to do power of power, so multiply that exponent in how many times? How many times am I going to have to take this 3 and multiply it into the brackets? Sorry? 3 times? Yeah? No? Maybe? How many exponents are inside of the brackets? 2? 3. Where's the third one? On the constant, right? I have my invisible exponent here that I technically have to multiply that to as well. So I'll multiply 3 to here, 3 to here, and 3 to here. So 5 to the power of 1 times 3. So 5 to the power of 1 times 3. X to the power of 3 times 3. And y to the power of 2 times 3. Now, I would usually not ever write that intermediate step, but it's there if you want it. So 5 to the power of 1 times 3 is 5 to the power of 3, which is 125 x 9 over y to the power of 6. Okay. Another exponent law from Math 9 is the zero exponent law, which is just saying anything to the power of 0 or anything to the power of 0 is 1. The thing that you need to pay attention to with that exponent law is where are the brackets placed? Because if there's a negative in there, that could change things. So just pay attention to that. And if you look through the notes that I gave you, there's a few examples for talking about zero exponents. The new exponent laws that we introduced this year are the negative exponent law and the fractional exponent law. So I'll take a look at both of those briefly, and then we take all of these exponent laws and combine them in a few questions. So first of all, the negative exponent law is saying if I have a negative exponent, to make that negative exponent positive, what we do is we take the reciprocal. And we took the reciprocal when we're looking at trig ratios. What else do we use the reciprocal for? Anyway, so to take the reciprocal here means I do what? Flip it. If I'm flipping this, what's it over? 1. So when I flip this, this is going to come to the opposite side of the fraction. And when I do that, it makes that negative exponent positive. So I'm bringing that negative exponent to the other side of the fraction. So in this case, to the denominator. So I bring it down, and I have to have something holding the top, right? It can't just be like this. That makes no sense because I need something to hold the place of the numerator. And so we put a 1 there. Big thing to pay attention to when you're doing the negative exponents is you're only moving that term that has the negative exponent. So if I have, 5x to the negative 2, to make that positive, all I'm moving is this x. So this would be 5 over x squared, right? Only move the term with the negative exponent. Not everything takes the reciprocal, only the term with the negative exponent. I can also reverse that exponent law, which means if I have something with a negative exponent on my denominator, so if I have, for example, 3 over x to the power of negative 2, to make that negative exponent positive in this case, where do I move it? If I take the reciprocal of that x to the power of negative 2, where's it going to end up? On the top, yeah. So you're kind of switching sides here when you have that negative exponent. So that'll come up. So this is 3x squared. So if you take the reciprocal of a negative exponent, which is moving it to the other side of the fraction, it'll make that negative exponent positive. Last one is the fractional exponent law, which is how to convert back and forth between a fractional exponent and a radical expression. So if I said, for example, x to the power of 3/4, what is that as a radical? Does anybody remember what you do here? Yep. Okay, Gavin? Yep. Yeah, so the 4, so whatever the denominator is going to become the index of my radical. So this would be 4 times x to the power of 3. And sorry, it's not 4 times, it's the 4th root of x cubed. So you take that denominator, and it's going to become the index. I can also undo that. So if I have, let's say, the square root of y, now this one's a little bit harder because a whole bunch of invisible numbers. So if I want to write this radical as a fractional exponent, what's the exponent on y? What's the index? 2. And so what I need to do to take this from a radical to a fractional exponent is undo what we just did up here. So I'll take the index, and it'll become the denominator of that now fractional exponent. So y to the power of 1/2. Kind of sort of remember that? Yeah. All right, so that's all the exponent laws. So now let's take those exponent laws and apply them to a few questions. The big thing that I kind of usually stress for exponent laws is make sure you simplify in the brackets first. Power of a power, so this right here, right, multiplying this out, this should be the last thing you do. Because otherwise people do power of power and they're, have to do power of power 10 times and they always mess up somewhere. So simplify inside the brackets first and then deal with power of power. So here's the few questions that I wanted to look at. Do you guys want to try these on your own, or do you want me to just bang through them real quick? 2a, please. Okay. All right. So I'm not even going to read that out because it's just going to sound really weird and not make any sense. But what I want to do, like I just said, is simplify inside of the brackets first. I also sometimes for myself, even like when I'm still solving questions, is if I know there's an invisible exponent somewhere or an invisible number, I'm going to put it there because it makes it easier to keep track of. So if I'm looking at this question right now, technically there is an invisible 1 on D that I need to account for. I can't just ignore that. So what I would do first of all is I want to divide these terms here to simplify. So this would be c to the 4 divided by c to the negative 2. So c to the 4 minus a negative 2 if I'm following my exponent laws, which gives me c to the power of 6. C to the power of 6. Again, I don't usually write out that intermediate step, but it's there. The next one then is to deal with d. So d to the power of 4 divided by d. So d, I'm going to subtract those, which is just 4 minus 1, which would give me d to the power of 3. I have not yet touched, that is all to the power of negative 4. So again, that's not going to be my final answer. Usually they at least get rid of power of power. So I would now have to take this negative 4 and multiply it in. And there is kind of two different ways you can solve this right now. You can get rid of the negative or multiply that in, but I'm going to multiply it in. So power of a power means I have to multiply those together. So c to the 6, thank you, times negative 4 is negative 24. And d to the power of 3 times negative 4 is d to the power of negative 12. That answer is not going to be on the test. Not going to be A, B, C, or D. So what? Yeah. Exponent laws, they always want your final answer to have a positive exponent, which means to make these a positive exponent, I need to recognize that this is a fraction over 1 and take the reciprocal. Because both of those have negative exponents, they're both going to come to the other side of the fraction. So on the denominator, I would have c to the power of 24 and d to the power of 12. That's on the denominator. What's on the numerator then? Yeah, we need a 1 to hold the place value. If there was another coefficient there, you could just leave it as like 5, but there's nothing there. So now, less than ideal, but could you verify your answer? Could you verify that answer? I could, right? I could go here and say, I'm going to make c equal to 2, make d equal to 3, type all that in my calculator, get an answer, type all this in my calculator, get an answer. The problem with that being, a lot of people are probably going to type things in on their calculator wrong, and even though your answers might be okay, your verification process might be incorrect. So that's a really hard one to type in on your calculator, but you can do it. Should I just keep going through these next examples? Okay. Yeah, I don't know. I mean, I'm going through them either way. Do you want to do them first? Sorry. Me go? Okay. All right. So next one, 36 x to the 4 y all to the power of 1/2. Is there anything I can simplify inside? Could I simplify anything in here? No? So that's already done for me. Like maybe there was something else, but I don't need to do anything there. What I do need to do is power of a power. So how many times am I going to multiply 1/2 in? 3, I multiplied here, and multiplied to the invisible 1 here. So this would become 36 to the power of 1/2. X to the power of 4 times 1/2 is just 2. And y to the power of 1/2 is just y to the 1 times 1/2 is 1/2. Sorry? Good question? Okay. 36 to the power of 1/2 can be solved, right? This is actually another way to write that is that could all just be square rooted. So 36 to the power of 1/2 is just 6 x squared y to the 1/2. So I might see my final answer like that. The other way I might see my final answer is 6x squared y, or sorry, x squared square root of y. Does everybody know how I went from here to here? No? Right, so I just brought this guy down. He's right here. And then if I'm ignoring that, I'm taking the 2 and it's becoming the index, so 2, and I'm left with a 1. Right? square rooting something and something to the power of 1/2 is the exact same thing. All right, C, last one for exponent laws that I'm going to look at. X to the power of 3/4 times the square root of x. The problem right now is those aren't in equivalent form. So if I need to simplify this to one exponent, what I would do is I would take this and change that to a fractional exponent. So I'll take the first one, x to the 3/4 is just going to remain the same. This here is going to become x to the power of what? Just said it like 30 seconds ago. Not even. X to the power of 1/2, yeah. Because there's a 1 here, there's a 2 here, the 2 becomes the index of that fraction, or the denominator, sorry, the index becomes the denominator of that fractional exponent. Now what I can do is use my exponent laws to help me solve. So same base, I'm adding those together. X to the 3/4 plus 1/2. If you were to add your fractions, actually add them, you'd have to get a common denominator, put that in, and then add them. We don't necessarily need to do that, right? We can just type in fractions on our calculator, and my calculator is going to spit out a fraction. If I go to that math fraction button with any decimal, it'll take any decimal and change it to a fraction. So this is technically just going to be 5/4. So x to the 5/4. That might be my answer. Or what's my other answer? Does anybody know? Other answer. Yeah. So so that could be my one answer, x to the 5/4. That's equivalent to take that denominator, becomes the index, the 4th root of x to the power of 5, right? So you might see either of those forms for your final answer on the test. And any other questions for exponent laws you guys have? Okay, there's a few additional examples on that review worksheet if you want to look at that, but that's it for exponents.